cracking. So, very first of all, we've done maybe not, we'll see, an experiment. Hopefully you were excited by the really thrilling experiment. Now it says over here, when we consider our results, bromine water is orange-brown. It turns colourless when it reacts with, hang on, I want a pen, not that. It turns colourless when it reacts with substances containing CC double bonds. Okay, so if it contains one of them, it will go from orange to colourless. Now, the original paraffin oil, okay, when we tested it, there was no colour change. Well, there should have been no colour change. Okay, therefore, no alkenes. However, on the cracking one, okay, it was decolorized. Okay, so alkenes are present. Fantastic. Now, it says, in general, the boiling points of alkanes and alkenes increase as the size of the molecule increased. What does that tell you? Okay. Increase. So the size of the molecules in paraffin are contained, the size of the molecules collected in the test tubes. Okay. So we need to think about the fact that paraffin is a liquid at room temperature, and the test tubes contained gases. Okay, they contain gases. They did. Therefore, the paraffin are the larger ones. Suggest a reason why the first few bubbles need not be collected. Okay, that's because they are mostly air. They are mostly air. Fantastic. Number 4, explain about the broken pot. The broken pot is a catalyst. Energy must be supplied by heating, otherwise cracking stops. Explain whether this shows whether it is exothermic or endothermic. Well, it's endothermic. Okay, because heat has to keep going in. Okay, you have to keep putting heat in for it to happen. Okay, now we have sheet 2, supply and demand. Now these are very common exam questions, okay? The kind of thing they might ask you, okay? State whether the fractions in the table are arranged in order of increasing size or decreasing size. So as you go down, the size increases. It does. The refinery produces more than one fraction than it can sell each day. Name this fraction. Okay, that is very clearly, it makes 800 of this, it sells 450. It's fuel oil. The refinery could sell more of the 3 fractions it produces each day. Name the 3 fractions. Well, obviously there are 3 that's left. We've got petrol, we've got kerosene, and we've got diesel oil. Using the correct answer to questions 1 and 2, what do you notice about the type of fraction in oversupply? Okay, so basically the oversupply, the one we have lots of, okay, is the larger molecules. Okay, now it says the oil refinery might have leftover barrels of the fraction identified. Okay, what could we do with the leftover barrels rather than dumping them? Well, we're going to do cracking, clearly. Okay, it converts long-chained hydrocarbons into smaller, more useful ones. These have a higher demand and are better fuels. Lovely. It also produces alkenes, which are good feedstock for feedstock, which means they're a raw material to use for something else. Brilliant. Now, last one, 4 sheets today. Blimey, we've got our strength in here. We do. So it says, complete the table using the ticks to show the features of each compound. Okay, so compound 1 is the largest. It is. Okay, compound 1 is the largest and contains the most CC bonds. Okay. Anything interesting about question 2? It contains CC bonds as well. Whereas, of course, compound 3 contains CC double bonds and is also the smallest one. There we go. Alkenes have CC double bonds. Give the compound number of each alkene in the reaction above. Well, it's just number 3, isn't it? Because there's your double bond. It's the equals between the C and the C. There's your double bond right there. Okay, unsaturated hydrocarbons have CC double bonds, but saturated hydrocarbons do not. How many unsaturated Now, unsaturated have double bonds. That's number 3. Saturated will be 1 and 2. In the sentence, underline the correct word in each pair. So, cracking involves breaking down larger. I'm going to underline it. Saturated hydrocarbons, which are alkanes, into smaller hydrocarbons. Some of these are alkenes, okay, which are unsaturated. Brilliant. Now, octane is a hydrocarbon found in petrol. Name the 2 products formed by the complete combustion of octane. Well, if you take octane, C8H18, if you react it with O2, what are you going to make? Well, you're going to make C and something with O in it, which is CO2, carbon dioxide. Why am I writing it? Because it told me to. It told me to name it. I'm writing the CO2 to help you work it out. Now, and then there's H and O. What can you make with H and O in it? Well, H2O, isn't it? Water. Okay. Remember, it says name. So name. Okay. Name a compound which also produces when hydrogen burns. Well, hydrogen obviously doesn't contain these C's, only contains H's. So that would be water. Because obviously you can't make carbon dioxide if there's no carbon present. Give one environmental problem caused by the other product, this one, okay, given, well, it's a greenhouse gas, isn't it? So global warming. Okay, and it says, in 2025 in the UK, there are almost 8,500 petrol stations, but 4 hydrogen stations. 2 advantages this gives to petrol-fueled cars. Well, you are more likely to live near a petrol station. Okay, and obviously you can make longer journeys as you have all kinds of places to stop to get your petrol. Okay, fantastic guys, there we go.